Thanks again for joining today's webinar titled Dotdot and Thread, Learn about the Specification and Streamlined Certification Programs. We're going to go ahead and begin. To start, all attendees will be placed on mute. And please note that this webinar is being recorded. If you have a question for our speakers, please use the question box located on the right-hand side of your screen. Questions will be read and addressed after the presentation. A recording of this webinar will be made available on the ZigBee Alliance and Thread Group website. We will send you a note after the webinar has ended. At this time, I'd like to introduce today's speakers. First, we'll hear from Daniel Mineta, the founder, Chief Marketing Officer, and Executive Vice President of Corporate Development at MMB Networks. He's also a board director and the marketing work group chair of the ZigBee Alliance, and he is also on the marketing committee of the Thread Group. We also have on the line Sujatha Naidig. She is the Director of Product Marketing at NXP. She's the Vice President of Marketing at Thread Group, and she's also a board director at the ZigBee Alliance. And we've got Victor Barrios, who is the Vice President of Technology at the ZigBee Alliance. And with that, I will now turn it over to Daniel.
Hey everybody, so thank you for registering and for attending. For some of you, this might be your first opportunity to learn about Dotdot and Thread or Dotdot over Thread. For some, you've been hearing about this for a couple of years now as we've hit key development milestones along the way. So we're really happy to talk to you today because Dotdot is now a ratified specification that you can start working with a healthy support and vendor ecosystem and a path to certification. So on that note, let's take a look at the agenda for the webinar today. So first, we're going to start with a brief discussion on why IP and application layers matter and why both of these things are key components of a complete solution for the IoT and for the smart home. Then we're going to talk a little bit about what exactly is Dotdot and Thread and how they relate to these key layers and key components. Talk about why this isn't yet another new standard, because the industry certainly doesn't need another one of those, but rather technologies built on ones that are robust and mature and well deployed. Then we'll dive into some key use cases about what Dotdot and Thread can do, what kind of products or use cases it's ideally used for, and how it not just compares to other technologies you might use, but how it actually works with those other technologies in the IoT ecosystem. And then we'll get into some specifics about the programs and ecosystem around Dotdot and Thread, so the specification availability and where to get that, the certification program, the commissioning tool, and other items that will be coming out in support of Dotdot and Thread, and of course vendor support. That should take up about half of the webinar time, and then we'll have plenty of time for Q&A because I'm sure a lot of this will spawn a lot of questions, especially that latter part around some of the specifics of its availability. So with that, we'll get started and talk about why IP and application layers matter. So those of you that know me know I love this quote. So I'm going to start with one of my favorite quotes about technology from one of my favorite articles about technology from one of my favorite authors. So Douglas Adams of Hitchhiker's Guide fame wrote a blog post in the 90s called How to Stop Worrying and Love the Internet. If you haven't read it, you absolutely should. You can Google for it and you'll find it. It looks like an article written in the 90s. It's a little bit dated now, but if you just do a find replace for internet with pretty much any new technology trend, it will suddenly become relevant again. And it's especially so today in the IoT. But what I wanted to pull out of that is Adams' somewhat borrowed insight that technology is just a word for stuff that doesn't work properly yet. Adams reminds us that while we don't think of things like chairs or light bulbs or maybe even door locks as technology, at one time they actually all were, and we hadn't quite figured out how they work best yet. And while we have a lot of patience for technology, we have remarkably less so for things that we take for granted, like these. You know, a crashed app or a restarting laptop usually elicits little more than a shrug of acceptance. With the Internet of Things, however, we're doing something we've never done before. We're adding technology, connectivity, and smart features to devices in categories that have been so reliable that we no longer think of them as technology. If an app crashes 1 out of 10 times on your phone and you restart it, you probably won't think about that for a second. But if your chair crashed 1 out of 10 times when you sat on it, that would be pretty frustrating. And that's the level of challenge we have right now in adding these types of technologies to products where the user expectations are extremely high for functionality. And so while this is creating remarkable new opportunities for brands to engage with users, it's also creating remarkable new opportunities for frustrations. Because when these things we take for granted don't work, it's quite frustrating. And too often in today's smart home, they don't work. And that's because we've been building the IoT in ways that are great for early experimentation, but that we know don't really scale. And we know this because we've been through this before. The early days of the internet looked a lot like today's IoT. We had a number of walled gardens with proprietary interfaces like AOL, CompuServe, MSN, and others that forced you to choose which internet you would be a part of. The one you picked determined what information you could access, what features you had, and who you could talk to. You're pretty much limited to whatever innovation that ecosystem vendor could provide. It was frustrating, it was unscalable, and innovation was slow. Now, this was probably the best way to introduce people to the potential of the internet, which was very new at the time, and to try and bring all of these disparate services and features under one or a few roofs, just like how the IoT works today. In fact, we're getting a lot of the same questions today too. People often ask whether Google, Amazon, or Apple is going to win the smart home in the way they used to ask whether AOL or CompuServe or MSN was going to win the internet. So on that latter question, we have hindsight now, right? It's 2018, it's the future, so who won? Right? That question doesn't even make sense now. No one won the internet, but rather we grew out of that early phase to a more open internet, creating a lot more opportunity, innovation, interoperability, and growth for everyone. So what were the keys to doing that? Today's open internet has proven to be a platform for limitless innovation enabled by two core technologies. The first is a foundation of IP that seamlessly connects every device on the internet regardless of what transport or radio they use. So Ethernet, Wi-Fi, fiber, 3G, 4G, 5G, etc. And even today, all of us on this webinar are probably connected via a number of different IP technologies or a series of different IP technologies. My computer in front of me is on Wi-Fi, connects via Ethernet to my cable modem, then to coax, then fiber, probably a range of other technologies in between. And many of you might be on cellular, LTE, or other connections, and yet we're all on the same IP network that allows us to connect and share information. It's very powerful, and it means that we can choose networks based on our use cases instead of arguing over which one is winning. And the second piece to that makes it work is open common protocols or languages. So in the internet's case, think of HTTP, FTP, IMAP, HTML, etc., that run over that IP foundation. Common protocols allow devices to communicate regardless of which brand of laptop, smartphone, or browser we're using, or what network transport they're using, and in fact work seamlessly over multiple transports simultaneously. These two pieces are why I can build a website and know that you can read it regardless of which service provider, device, or browser you're reading it on. It's why you can buy a router from one of many different vendors and still access whatever content you want. It's why you can change your phone and still access all the services and data you had before. It's how our entire connected world works. It's the fundamental connectivity platform and approach in every one of our pockets and the ones that will be there tomorrow. Dotdot as a common language for IoT devices, together with Thread as an IP network for IoT devices, literally extends that powerful platform for innovation to the Internet of Things. So just to understand what that means, I'll talk about languages for a second. So this is a simple analogy we often use to illustrate the difference between connectivity and interoperability, and I found it's quite useful for audiences at all stages of the IoT. So let's imagine you and I want to communicate wirelessly. So we buy a pair of walkie-talkies that use the same radio and frequency. Now we can connect to each other. That's connectivity. But if we don't speak the same language over that radio, we can't really do anything interesting together. We're connected, but we can't really interoperate. Only with a common language can we work together to do valuable things, even if we're from different places and have never met before. Today we do a lot of this through translation on the internet, but you can all imagine the difference between the richness and reliability of a conversation where both people are speaking the same language rather than one where there's a translator in between. So this is where Dotdot comes in. And this is a challenge, this common interoperability language that ZigBee Alliance and members have been working on and deploying for over a decade. So ZigBee is a full stack technology. That means it includes both the network layer and the application layer, that common language between devices. In ZigBee terminology, this application layer has been called the ZigBee Cluster Library, or ZCL. The ZCL is a standardized set of device definitions, behaviors, and security models. For instance, it defines how a light bulb joins a network, how it communicates whether it's on or off, what brightness it is or color it's set at, and how other devices and apps can adjust at those settings. And that enables different vendors to build and certify products that will work with each other without one-off integrations for every interconnection. That ZCL is the common language that already enables interoperability amongst millions of devices working together in homes and businesses, from major companies including Philips Hue, Comcast, Samsung SmartThings, IKEA, Osram, Kwikset, Belkin, GE, Yale, Amazon, and many others. To date, this mature interoperability language has remained at the heart of ZigBee. But there are many new use cases that call for different types of networks, and most especially of late, IP networks. And so ZigBee Alliance members, having seen the value of the ZigBee cluster library in deploying millions of products worldwide, endeavored to bring this technology to IP networks. The result of that work is Dotdot. Dotdot is a common language for the smart objects we rely on every day so that they can speak to each other effortlessly on any network and make themselves more useful to all of us. If this sounds similar to what I just said about the ZCL, that's because it is the ZCL. Dotdot specifies how to use the universal language of the ZigBee cluster library, that standardized set of device models, on IP networks. Informally, we've called it things like ZClip or ZigBee cluster library over IP, but obviously that name doesn't quite flow off the tongue. And so we wanted to give this technology a good brand and some breathing room from ZigBee from a brand perspective so that developers and users aren't confused about them. So we gave it a new name, Dotdot, to identify it in a more user-friendly, network-agnostic way. Thread is also a familiar technology in new clothing. Thread is an implementation of the same IP technology that drives every internet-connected device you've ever used. The difference here is it's designed specifically for IoT devices. Thread is often compared to Bluetooth or ZigBee, but really its closest comparison is Wi-Fi. Just as Wi-Fi was designed for local high bandwidth devices, Thread was purpose-built to support reliable networking for the kinds of low-power, battery-operated, widely distributed devices that make up most smart home or commercial IoT applications. And because it's IP, Thread enables these types of devices to connect directly to the internet and to other local IP-based devices, whether they're on Wi-Fi, Ethernet, or other IP technologies. Thread devices simply become part of the tapestry of the home IP network, just like all of your other IP-based devices. Together, Dotdot over Thread is the first solution that implements an open, interoperable device language running over an internet-based network. Just as open universal protocols like HTTP over IP unlocked and accelerated innovation on the internet, Dotdot's common device language over Thread's IP network brings that foundation for innovation to the Internet of Things. So one thing that's you're going to hear as you've certainly already heard as a common theme, and will continue to hear, is that although some of these are new brands and new names, these are not new technologies. These are mature technologies that have been adapted to the needs of the Internet of Things. If you're in any way involved in standards, you have probably seen this XKCD comic before. If by some miracle you haven't, I'll give you a moment to read it. Even if this is something you haven't seen before, you've almost certainly experienced it before in this industry or others. And nowhere have I seen this cited more than in IoT discussions. It seems like every other month there's some new standard or consortium But new standards, even from established organizations, can take years to mature, to become reliable, to develop a robust supply chain, for developers to gain expertise, and for it to proliferate. For product vendors looking to create products and platforms that will need to be maintained and in users' homes for years and hopefully get to market sooner than later, those new standards can represent risk. So what we didn't need or didn't want to build was another new standard. So if there's one take home here again, it's that Dotdot over Thread is not another new standard. They may be new brands, they may be new packages, but inside are two of the most robust, widely deployed, well-known, and well-supported connectivity and interoperability technologies. These are technologies that drive billions of products and networks already in our homes and offices, now extended to the low-power IoT. As the foundation of the internet, IP will continue to be supported well into the future. Choosing Thread and IP means your device will always have a network to connect to. And Dotdot has been developed by the ZigBee Alliance, an open global nonprofit organization. It continues to be driven by member companies at every level of the market, and everyone has an opportunity to bring innovations to the table. The ZCL is now at version 3.0, having been developed, evolved, deployed, lessons learned for over 15 years, and so it brings the maturity that can really only come from real-world deployment at scale, and now it brings that to IP in the form of Dotdot. All this means that both Dotdot and Thread already have global competitive supply chains with multiple vendors at every level and experts with years of experience deploying these technologies in the real world and at scale. This includes companies like these on the screen here, as well as dozens of others that have contributed to the process and that support different pieces of the solution, like underlying components like thread stacks, silicon and reference designs, and even fully finished products like border routers. It's this solid foundation that's why major product and platform vendors already in both organizations are currently building products with Dotdot and Thread. So Dotdot over Thread is a great platform to build on from a product management standpoint, but what new value does it bring to the table? So I want to take a look at some specific use cases and how Dotdot and Thread enables new applications in the IoT in ways that other technologies might not while working alongside them. So let's talk about what applications Dotdot over Thread unlocks in the smart home, though these concepts are applicable to other areas of the IoT, of course, including MDUs and commercial applications, and we'll have some notes on the latter shortly. So let's say you're a product developer and you're creating a device or ecosystem of devices and that you need those products to do one or ideally all of the following. You need them to connect directly to your cloud so that you can maintain a relationship with the device and the user, learn about the user, provide updates, adjust features over time. You need it to connect directly to users' mobile devices and apps. You need it to interoperate amongst your products and possibly other third-party products in the home. And you need it to do things like last for a long time on battery power, not require a lot of additional first-party infrastructure that you'd have to provide just to get it to work. And of course, you always want it to be as easy to support as possible. So there's a variety of technologies for addressing these needs on the market, and let's look at some of those. And of course, when we talk about other technologies, it's not to say that they're bad or that everything will be Thread or Dotdot over Thread. We live in a world that uses multiple technologies for the right applications. So as we look at these options, we'll talk about why Dotdot over Thread is the right technology for this application, but also about how Dotdot and Thread work with these other technologies to create a better experience for users. So let's talk about non-IP technologies, and one that's important to talk about is ZigBee. So as we've discussed, ZigBee is a highly interoperable technology that powers millions of devices already out there in the field with commercial success. But one factor with ZigBee is that all devices need to connect to a single gateway. Now, if that gateway is someone else's, you don't end up having a direct connection to that device. If that gateway is yours, you're now responsible for selling and maintaining that gateway, and it becomes a necessary component of your product. And you're also on the hook for potentially supporting any other devices that connect to it. Now, for some, like security and smart home ecosystems that want, all roads and all devices to connect to their ecosystem, this is a great model. It's a great way to provide a unified ecosystem to a user. But for a vendor that wants a cloud-connected device, but not necessarily to own the entire ecosystem, that's a challenge. It should be noted, however, that because Dotdot and Thread devices speak the same language as ZigBee devices just over different networks, they can also be bridged if there's a need to without arbitrary translations between protocols. So these technologies work really well together, allowing new Dotdot over Thread devices to exist in ecosystems that currently have ZigBee devices in them. So a lot of people look at Bluetooth as a smart home technology because, hey, it's low power, and of course, it connects to users' mobile devices. And that's true, and there's a lot of great applications for Bluetooth for mobile accessories for that reason. But there are some challenges here. One is that the behavior of Bluetooth and even the user experience or interface around that on any particular model of phone or certain combination of user settings can be somewhat different. So that's something you'll have to support. And you'll have to deal with multiple mobile devices connecting directly to your product, if you can even support that. Another challenge is by using the phone as a gateway, now that phone has to be near your device and transmitting in order to ferry information between the device and the cloud. So that's going to be particularly problematic for applications that need always connected functionality to provide value to the user or to you as a vendor. Okay, so I'll build a Bluetooth to Wi-Fi bridge. We certainly see a lot of these in the market. So you can do that, but now once again, you've added another proprietary box that has to ride along with your device. And because there are not yet any mature device profiles for Bluetooth, everything about that box is going to be proprietary. So that's something you're going to have to own and maintain. And the irony of doing that is all that work now just negates your primary reason to choose a technology like Bluetooth, that it connects directly to phones, because by having a gateway, you've eliminated the need for a phone to talk directly to the device. It can talk through IP or it can talk to the cloud. That becomes even more problematic when talking to other smart home devices. With traditional Bluetooth functionality, there's usually no way for your product to connect to multiple other products in the home, certainly not simultaneously. Most devices can only talk to one other thing at a time, which is problematic for a large smart home ecosystem. Even if you do connect one-on-one or use a technology like Bluetooth Mesh, there's no standard device profiles. There's no common language outside of lighting yet. The Bluetooth SIG is getting started to think about those, but that's going to take some time. So today, there's simply no way to be out of the box interoperable with other products unless you coordinate with them on a one-to-one corporate level. So what we keep finding is that developers often sacrifice a lot of functionality by choosing technologies like Bluetooth just for a couple admittedly very useful features like mobile connectivity. But they don't have to. The current state of the market is that a lot of silicon is multi-protocol. And so most Thread chips support Bluetooth alongside Thread. So this means you can get best of both worlds. You can get all of the benefits of Dotdot over Thread for IP-based networking, connectivity, interoperability, and still leverage Bluetooth for direct-to-mobile functionality like out-of-the-box commissioning of devices and local connectivity for third parties. Okay, so what about Wi-Fi? It's in everything, it's IP, so it'll talk to mobile devices in the cloud, and everyone has a Wi-Fi router, so you don't have to provide the box. The challenge here, though, is that Wi-Fi is significantly more power intensive, often requiring compromises on user experiences to extend battery life. There's also no standard for Wi-Fi IoT interoperability yet, so anything you're doing on top of Wi-Fi is proprietary, and all interoperability has to be in the cloud. And this is how a lot of pieces of all of our smart homes and businesses work today, where you can have a device that's 2 feet away from each other, but it's going through 50 different pieces of hardware on the back end just for a switch to turn on a bulb, any one of which can hiccup, causing issues in the home. So that creates a lot of reliability challenges and some big support challenges. For instance, if your users change their router or password, all of your devices disconnect, and you have to commission them one by one. And these types of devices are typically kind of a pain to commission, so hopefully they will actually reconnect your device. And we've seen a lot of companies that have issues where a user is willing to set it up, but once it disconnects, they're not willing to connect it back unless it's providing a ton of very necessary value. Another issue is that Wi-Fi is a very high bandwidth connection into a home or business, especially when a lot of IoT devices need far, far less. And this creates a potential security issue. Your device is more of a target when you have this sort of permanent, forgotten about high bandwidth connection into your user's network, and most of that bandwidth is going unused. But you also can't ignore Wi-Fi, obviously, because it's everywhere. It's a great option for connectivity out to the internet and on everyone's mobile devices, and powering a lot of the smart home today. And that's fine because Dotdot over Thread works over IP, so Thread devices become part of that greater IP network alongside Wi-Fi devices and can communicate directly with them. And in the future, Dotdot will work over more IP protocols like Wi-Fi, enabling more unified networks. So Thread and Dotdot brings all the benefits of Wi-Fi with additional value. It's IP, so it exists on the network and can talk out to your cloud, to users' mobile devices, whether they're in or out of the home. It has a common protocol in Dotdot for device-to-device interoperability, so you don't have to reinvent and support a proprietary protocol, and can talk to other devices. And it's built for lightweight, resource-constrained devices, so it's great for battery-powered products, and it requires less infrastructure. On that note, we get a lot of questions about border routers, and certainly, yes, today you may need a border router to connect a Thread device to Wi-Fi or Ethernet, but it's important to note that in Thread, the border router is a generic device type, so it's much like a Wi-Fi router. You don't have to customize it. It's available from a number of vendors out of the box, and eventually that technology will be folded into Wi-Fi routers. Routers like Eero already have this technology in them, so over the lifetime of your product, you'll start to be able to provide less and less infrastructure. And even today, you can source that piece from multiple vendors without having to build it yourself. And there are even ways that there's a plus that Thread devices and Dotdot over Thread devices are on a network that's a little bit separated from the Wi-Fi. For instance, the user can change their Wi-Fi passwords without disrupting the entire smart home or IoT network. And if you have a border router, all you have to do is commission that one device and everything is back online. So it creates a much easier process for supporting customers. So Dotdot over Thread often gets positioned competitively to any of these technologies, but really that's not appropriate here. Dotdot over Thread delivers significant unique benefits. It is the only low-powered IP network with a mature interoperable app layer. It's the only IoT technology that brings the foundational approach of the internet to the smart home and IoT, scalably supporting large networks of low-power devices. And rather than competing, it works alongside or even supported by these other key technologies. So I've talked a lot from a consumer space framework, and all of these concepts obviously apply to everything from consumer to commercial to industrial IoT, but I want to spend a minute just talking about some commercial specific applications. Dotdot over Thread enables scalable flexibility in the commercial space as well. Devices that all speak the same language and are on the same network make it easier to manage. In fact, as an IP technology, Thread devices fit right in with most buildings' existing infrastructure and management systems. With Dotdot as a common application layer on top of that, the network can be used to coordinate many types of devices on a commercial network, not just one limited application like lighting. Again, we see people looking at other technologies like BT Mesh for these applications, often just to take advantage of one key feature like commissioning products for mobile devices, which is especially important in the commercial space. But again, with Dotdot over Thread and multi-protocol chips, you get all the advantages of mobile-to-device connectivity for commissioning and location, but can use a far more robust, flexible, and manageable IP backbone for building infrastructure. And at the same time, larger buildings might want to separate devices into different operational networks with different management or security levels, or even different application layers, but still leverage the strength of the mesh. Dotdot over Thread enables this too, because you can connect multiple devices on an IP network and run multiple application layers on top, or segregate devices into their own logical networks. So let's talk about how to actually get started and get to market building Dotdot over Thread products. So the first thing to note is, and the most exciting thing to note is, Dotdot is available. So you've been hearing about this for a while. We've been very excited to announce milestones along the way. We announced Dotdot when we kicked it off, when we hit important development milestones where vendors had already implemented early versions. And now we're excited to announce that Dotdot is a fully ratified spec. That means it's stable, it's ready for implementation, it's not subject to frequent changes. Now, of course, as an alliance, the ZigBee Alliance continues to evolve specifications in order to meet the changing needs of the market, but Dotdot having achieved ratification means you can start building with it today and know it will remain stable with updates in the future to add new functionality. Today, the Dotdot spec is available to ZigBee Alliance members. So if you are a member, you can find the spec at our ZigBee Alliance workspace. If you're not a member, please contact the Alliance and we'll show you some contact information in a moment to find out more about how you can join and access these specifications. And of course, the thread specification is also available. You can find that at the thread resources page at threadgroup.org/support. Now, of course, one of the key benefits to a ratified specification is that it's also certifiable to assure interoperability between devices of different manufacturers. There are now multiple test houses authorized to certify Dotdot and thread devices. But we also recognize that while certification is critical to interoperability and it creates a lot of value for the industry, it's also a hurdle that vendors often have to get over from an administrative standpoint. Along pursuing multiple certifications for one product can sometimes be a burden. So the ZigBee Alliance and Thread Group have been working together alongside our mutual test houses to ensure that there will be an ecosystem of certification houses able to offer a one-stop experience so that vendors can cut one check, sign one set of documents, and achieve both Thread and Dotdot certifications. So today, TUV is the first mutual certification house to offer both of these certifications, with more labs to be announced in the coming year. Vendors who wish to certify need to be members of both Thread and ZigBee organizations and will receive 2 certifications, one for Thread and one for Dotdot. As part of the Dotdot and Thread ecosystem, the ZigBee Alliance has also been developing a Dotdot commissioning application for mobile devices that's built on top of the original Thread commissioning app, for those of you familiar with that. This gives developers a tool for creating Thread networks and joining Dotdot devices to it, and also a code base for inclusion in your own product apps. And one of the most important things is that Dotdot over Thread is supported. So Dotdot and Thread software, hardware, and development support is available from multiple vendors with more to come. These on the screen are some of the companies, including mine, that worked on the Dotdot spec and built devices to take them all the way through to ratification. But there are a lot more companies involved in both organizations that support Thread and Dotdot at all layers of the solution. So please contact the ZigBee Alliance or Thread Group, contact these companies, or go on the ZigBee or Thread website to learn more about the products and vendors that can support Dotdot and Thread. But of course, the best way to get started is to join the Thread Group and ZigBee Alliance, get access to the specifications, and see how your peers and the rest of the industry is moving forward with Dotdot and Thread. And you can see below, and we'll make this available to everyone again afterwards, contact information for ZigBee Alliance and for Thread Group. And I think that now brings us to our Q&A, and I can see a few in the queue here. So I'll hand this back over to Sujata and Victor, and we can address some of your questions. Thanks very much.
Great, thank you, Daniel. Let's go ahead and jump into our first question. And of course, if any of the attendees have questions, please go ahead and put them into the question box on the right-hand side, and we'll be happy to answer as time permits. So our first question, are devices using Dotdot over Thread interoperable on the same network as devices using ZigBee? And are they certified in the same way? And Victor, I'm going to pass that over to you.
Thank you very much, Anne, and thank you very much for that question as well. We have to remember that Thread and ZigBee, while they're both mesh technologies working on the same underlying radio technology, which is IEEE 802.15.4, they are in fact different networking technologies themselves. So ZigBee devices and Thread-based devices will not be logically operate on the same network. So as long as there is a device within the two networks that is able to communicate with both sets of mesh networks and is able then to navigate the translation between one encoding to the other, Dotdot would interoperate at the application layer between the two. Simply all that you need is a device that's able to take the data that's encoded in one way, right, when it's running over a thread network, and re-instantiate it in a different encoding over the ZigBee network and vice versa. Then the devices will interoperate. Even though you're doing that translation and encoding, it's important to know that the data itself will not change. It's just obviously when we're operating Dotdot over a thread network, the data is represented in a particular manner using CBAR encoding and COAP and all other IP constructs, whereas on the ZigBee side is more on a byte-wise binary type representation, but the data itself does not change. So from that perspective, they are interoperable indeed. As part of the certification side, obviously, on the network side, there's a different certification regime for the thread network that there is for ZigBee. But if we focus again on Dotdot and the application functionality, it is a single test plan, whether the implementation is running over a thread network or a ZigBee network. So the device itself would be, tested against the same criteria on both cases, because again, it's carrying the same data, it's carrying the same functionality. So from that perspective, yes, they will be evaluated against the same criteria.
All right, great. Thank you for that, Victor. Moving on to our next question, is Dotdot over Thread limited to any specific device types at this time? And Victor, I think I'll pass that one back over to you.
Yeah, thank you, Anne, again. And on that particular one, when the certification program opens later this quarter, there'll be a first set of cluster functionality that would be supported. That was prioritized by our joint members in terms of the products that they were looking to introduce into the marketplace first. So that would mostly be addressing lighting related products. But that said, obviously work continues within our members, again, to bring in, not specification because that's already said, but to bring all the updates necessary to the test tools and in terms of test scripts and everything else, so that the entire catalog of functionality that is available today on the ZigBee side would also be available shortly on the Dotdot over Thread side.
Great, thanks, Victor. The next question we have, if you build a product that uses a certified thread stack, do you also need to join the thread group, or can you just join the ZigBee Alliance and certify for Dotdot?
I'll go ahead and take that one as well. And thank you very much for bringing that out. The thread certification continues to be a program and managed under the thread group. So for any product that is seeking thread certification, that will continue to be managed with the thread group and their policies and procedures, which do require membership in the thread group in order to achieve that level. Similarly, with the ZigBee Alliance, requires also membership to participate in the Dotdot certification program.
Yeah, Victor, I'll just extend that to say that if you have a thread certified stack, and it's using thread IP, then you do need to be a member of the thread group. Just to reiterate your point.
Yep. Thank you, Sujata.
Great, thank you guys. Our next question here, do I need to wait for other companies to make Dotdot over Thread devices for this to be useful? Sujata, do you want to take that one?
Sure, Anne. No, you don't need to, because one of the key benefits of this is that even if you're building just one device, or if you're building a few devices that are meant to work together, it's useful as a best-in-class interoperability capability, having cloud-connected technology, so you don't have to invent that yourself. You can still connect to the cloud and interoperate with other products there, but you'll also have the option to interoperate locally as the ecosystem expands.
Great, thank you for that, Sujata. We've got another question here. Are there any known network size limitations? Victor, do you want to answer that one?
Yeah, on the ZigBee side, obviously for the mesh network there is some addressing limitations in terms of how many addresses can be handled in a network. That's upwards of 65,000 addressing space, so that is pretty large inherent to the network itself. Now, practically speaking, we see our members and deployments to limit that size more from a operational management perspective, because then they can limit it to a specific location or deployment within a building and things like that. But from the protocol, now I'll request the help here of my threat colleagues to answer that with respect to the threat network.
Sorry, which question about the network size?
Correct. If there's any particular limits or suggestions in terms of network size on the threat side.
No, I mean, we have silicon providers who have tested the network size up to 300 nodes, but you can have subnets also to be able to address even more nodes than that. So that's the perspective from the networking layer.
All right, great. Thanks, guys. The next question we have is with regard to the certification transfer program that the ZigBee Alliance offers. So do certification transfer program members have access to the Dotdot spec?
Unfortunately, no. The certification transfer program members' benefits are limited to the leverage of an existing alliance member certification for the purposes of achieving certification on their own branded product. But as with any of the other ZigBee Alliance specifications, that is limited to access to members of a adopter, participant, or promoter level only.
Okay, great. Thank you, Victor. Okay, our next question. If devices using Dotdot over Thread cannot logically run on the same network and I need a gateway for translation, is there a reason why I wouldn't use Dotdot over Thread versus the full stack of ZigBee?
I guess my question there would be logic cannot logically run on the same network as what? I think if the question is running it over, like between like Dotdot over Thread and over Wi-Fi, I mean, once you've joined the greater IP network, you are sort of on the same network. If you're saying a gateway, you mean like a border router. It's not actually translating. It's more just moving information between the Thread network and, let's say, a Wi-Fi or an Ethernet network. Typically, where people use gateways, or you would use the term translation, is where you're actually working between two different protocols or protocols running on different types of networks, like, as you say in this example, Dotdot over Thread versus full stack ZigBee. And that was one of the points I was making earlier, which is, although they're sort of speaking over different technologies, because they're using that same language, the device models are the same, the way those devices sort of see the world is the same. You're not so much translating as just sort of changing the form factor of the messages to the other network. So it actually makes them quite interoperable, and it makes it quite straightforward to build a bridge if your application requires that.
Okay, great. Victor, Sujata, did you have anything to add to that one?
No.
Daniel did a great job as usual.
Yep. All right, fantastic. Thanks, Daniel. Our next question, based on what we've talked about regarding ZigBee's interoperability and Thread, is Dotdot interoperable with Bluetooth, and are there any other plans for development? We've actually got a couple questions that have asked similar content.
So today, obviously, and the purpose for this webinar was to introduce our first, I'll call it non-ZigBee availability for the Dotdot application layer, and that is obviously over the thread network. Today, that's the only implementation that is available for use and certification on, again, on a non-ZigBee mesh network. There are in discussions and plans to go over different networks. Those are just still in the works.
Great, thanks, Victor. And we've got a question here about the status of the commissioning tool. Do we have the status of that or a timeline? Victor, I'm going to pass that to you again.
Yes, so the commissioning tool is undergoing the final acceptance testing. We anticipate that we'll make that available concurrently with the opening of the certification program, so that when the program opens, we'll have obviously the availability of our testing partners to perform testing on our members' products, but also availability of the test harness for our members to do preparation in anticipation on going to those test labs. And then we'll have the commission and application available at the same time. So it'll be a complete package that will become available at the same time.
Okay, great. Thank you, Victor. And we've got a clarification question about the certification. So what parts get certified within the ZigBee Alliance and which parts get certified by thread groups?
So the thread group obviously would test and certify implementations of the thread networking protocol, and the ZigBee Alliance would test and certify implementations of the Dotdot application layer.
Great, thank you for that clarification, Victor. Our next question, what is the recommended number of nodes or devices connected to a single border router network?
I'll come back to that one. And if you can just skip to the next question, I got to look up something just to validate the answer.
Okay, sure thing.
Okay, I just wanted to validate it, what I had in my head. So 512 is what is capable of being supported by one border router. Actually, by one router. So there's one thread router can support up to 500, let's say 11 nodes, and then there can be up to 32 thread routers on a single border router. So hundreds of devices.
Great, thank you, Sujata. And we've got a few more questions rolling in. If you've got any more questions, please do add them. I guess this is for, I think, both the ZigBee Alliance and thread group side. What types of devices do you expect to be certified, and what types of products do you expect that the market will see first?
I can answer some of that. So, and I'm sort of speaking from my perspective, because my company helps others create those connected smart products. And a lot of the early interest we're seeing in Dotdot over Thread devices are from companies that, want to come to market first with like maybe one product or a few products that, I almost want to call it like they're like Wi-Fi light products. They need an IP connection. They need a connection to the cloud. They need to be able to talk to users' mobile apps, but they're battery operated, or they're going to be a few distributed through the home, and they want to take advantage of mesh networking. And so those tend to be the initial applications, because as we talked about before, Dotdot over Thread really gives you the best of both worlds. It's a great way to make a single device that connects to your cloud and to users and is low power and good on battery, but it also opens up the possibilities for easy interoperability with other products, whether they're from your company or from others. So that's typically, at least again, from my perspective, others might have others, but we're seeing a lot of those like smart home companies, consumer packaged good companies, et cetera, start to use that in the smart home.
Great, thank you, Daniel. And it looks like our last question here, will the Dotdot spec become available for thread group members?
Yeah, so this is something that our boards of directors are discussing now, as well as other opportunities for us to streamline potentially certification process in the future. As it stands today, it's only available to ZigBee Alliance members, but that is something obviously within the framework of cooperation we have between the two organizations that will continue to be monitored and adjusted as needed.
Yeah, and I would say that Thread Group and ZigBee Alliance have a lot of common board members, and also that the two organizations have been working together very closely and really looking at how to remove roadblocks and challenges and in the industry and speed up the innovation. So
Okay, great. Well, thank you once again. Oh, we just had another question pop up. Let's see. Going through two certifications could cause a lot of overhead for manufacturers. Are there any talks to merge the certification programs and only have one certification?
Well, so I think, that was something we had discussed in the webinar. Want to be careful with the wording here because Thread is responsible for the Thread certification process and ZigBee is responsible for the Dotdot certification process. We're not calling it a joint or a merge certification process, but what we are working to do is make sure that there are a number of test houses, TUV is the first one, as we noted, that are authorized to do both. So you still technically are getting two certifications. You're still technically, paying for two certifications, all of that. But from a practical administrative standpoint, you're cutting one check. You're right. You're doing one contract. It's effectively to the vendor a merge certification process, but you do get both, or you can go to different test houses for either one, depending on your product development roadmap.
Great, thank you for the clarification, Daniel. And with that, we are going to wrap up today's webinar. Thank you again for joining. You will receive a link to view the slides and recorded webinar in your inbox, but please don't hesitate to reach out if you have additional questions. We wish you the best of luck building with Dotdot and Thread, and we look forward to seeing your certified devices soon. Thank you, everybody.